Okay guys, today's video is going to be on the BK portable smart batteries and what makes them smart and what makes the ones that aren't smart not smart, and what they can do and what they can't do. And also I'm going to go over the intelligent BK chargers and compare it to a simple non-intelligent charger from Endura here. And then I'll pull up a drawing, go over some of the particulars of how the things work, and then also go over discharging and testing of the batteries as well. So to start off with, just to kind of go over briefly on the internal construction of the batteries, they have a series of 3 lithium-ion modules. In this particular case, they put 3 cells together in parallel to form one, and the 3 then go in series to give you the your voltage here. And I'd like to start off with the 3 different kind of batteries that you can have. You can have a battery that's completely dumb, one that's kind of smart, and then one that has the full intelligence. Starting off with one that's completely dumb would be one that's on a clamshell, powered by AA batteries, or in this case on a power supply with a battery eliminator. And if you look at my display here, you'll notice I don't have a battery symbol here showing me my state of charge. And if I hit my battery stats button, it'll just say my battery life. It'll just say battery stats unavailable. So this represents the lowest kind of battery indication. The only thing it can do for you is that when it gets to 9 volts, it will trip your low battery alert chirp here and symbol, and it'll stay in that low battery state until the voltage comes up to 10 volts or above. So let me turn it down here and show you how I can trip the low battery. And then once it's there's the low battery chirp, and you see it sits there and flashes. And if I come back up, it'll reset. So that's your like I said, your absolutely worst case scenario. You're on a clamshell. You'll have absolutely no indication you have a dead battery until you get down to where you're almost dead, and there'll be almost nothing left at that point. So not a great indicator for you, but it is what it is. So this is one that would represent one that had no intelligence whatsoever. The next type this one here is aftermarket. It's made by a company called OSI, and this is a BK 0101. Both of these would be considered non-intelligent, but the truth is that they both do have some intelligence. They both have a circuit board installed in them that does monitoring and can give all kinds of stats and all that kind of stuff. So let me give you a demonstration of that. I'll take the OSI one here and fire it up. And when it comes on, what happens is that the little board in here gets pulled, and it responds and gives the radio information. And you'll see I now have a battery level indicator here, and if I hit my stats, I'll get the information. However, if you want to get the detailed information, you can come in here under menu and go to system test right here, and then go to battery statistics. And now it'll give you all the battery statistics for the battery, which is the current state of charge, the remaining state of charge, how many cycles it has, all these kind of facts that you would, the details about the battery, that you would think, well, hey, this isn't supposed to be a smart battery. How does it know all that stuff? Well, it's because the quote-unquote intelligent battery, which would be one of these here, which is a 0103E. What this one does, it takes the intelligence to another level, and it allows the charger in here to do some alignment, some voltage calibrations, and it also allows it to be discharged via the charger as well. And it's serial numbered, and I'm sure it's got a couple other fancy little options that it can do that this one doesn't. But don't be fooled. These non-intelligent batteries, both the BK and the aftermarket one here, they have a lot of information inside them that this board does. Now, before I get into the drawing here, I just wanted to show you that this battery here, this OSI, and as you can see, it's giving a low battery indication here and says it's only 10%. This is the classic example of a battery that needs to be recalibrated, because it's actually fully charged. It's 12.5 volts right now. So its only problem is that its brain only thinks it has a little bit left. Now, I could take a piece of tape and cover this center conductor right here so that it can't talk to the radio, and now the radio won't have that little bug in its ear that it's got a low battery, and it could be used all the way down without it giving you bogus indication. Now, this is the one that needs to be recalibrated, and we're going to go into that here in just a little bit. But the main thing for recalibration is that they're supposed to be able to do it themselves if they get taken all the way down, discharged all the way, and then allowed to be charged all the way back up again. That gives them 2 set points. And what happens is when it gets only surface discharge and not let discharge all the way, it has this weird, it's almost similar to like a memory effect that the old NiCads had, but it's not a real memory, because the lithium-ion batteries themselves aren't suffering. It's just the smart board inside that's having the trouble. So one of the other things I wanted to talk about with between the BK charger and the Endura charger here is that I found on several batteries already that were really low and needed to be completely recharged, that when I put them in the BK charger, the BK charger it would kind of charge them, but it would never actually put a full thing. You'd want to sit there and intelligently talk to it forever, and it would never actually come out of the doldrums of its 10 volts or whatever. But I could take that same battery, the same BK intelligent battery, stick it in the Endura here, and then Endura just kicks on the thing and just charges it up. Then take it back out of the Endura and stick it back into the BK, and now all of a sudden the BK likes it and will do its full normal operation. So I highly encourage you to get at least one Endura, just non-intelligent charger, so to speak, that it can just put some good voltage on it and get it going. I found once they were both going that they seemed to perform about the same. I actually timed 2 batteries that were both discharged, and they took them about the same. They charged them to the same level. I could find no difference. So I didn't, no complaints with the Endura as far as that's concerned. So, but yeah, the key to getting these batteries to work is to get them to fully discharge. So I'm going to cut over to another video here where I show you the little jig that I got set up to fully discharge them using a fan. That way I don't have to waste a radio by, the poor man's way of killing a battery is just to go over to like the Weather Channel or to anything and just leave the radio turned on and let it naturally die with the radio. But I don't like doing that to the radio, and also needed a way to actually confirm that the battery could put out the correct load for the correct amount of time. So I'll go into that next. But after that, I'll finish up with the drawings and the theory behind what's going on. So stand by for the discharge video. All right, I'm going to show you how I discharge the batteries and test them. What I have is a 12-volt fan, and I have a little board with some contacts soldered to the end of it, and a little clamp here, and I just put them to the battery. And this 12-volt fan has two settings, high and low. The high is 2 amps, and the low is 1 amp. So and just FYI, a 5-watt radio at VHF is drawn like 1.5 amps. So you can use either test, and what I'm looking for is I'm actually looking for a time. So depending on the capacity of the battery, it should last at a certain current draw for a certain length of time. So it's just a matter of starting the fan, and then starting a timer, and then recording until it dies. And I just keep track of the voltage so I can see when it starts to get to that knee of failure around 10.5, and to take it all the way down until it cuts out. So anyway, let me go ahead and give you a demo. I'm going to go ahead and turn the fan on and do a current measurement in the low and then in the high position to give you an idea of what it works. Okay, so I got my ammeter ready. Here we go. We're going to turn it on, and I'm going to come over and let's see if we can get a reading here. 1.1, and then if I come over, make sure I don't hose anything up here, and if I go into the high mode, two point one. Okay. And like I said, I'll just set this on a timer and watch the voltage and see how it happens. See what happens. This is the only true real test that you can do on a battery. All the other ones are just simulations, but the actual work time under a load is. All right, if we're here looking at the schematic of the circuits here, starting off with the battery, we have the 3 cells, which is actually three cells. We have this essentially the circuit board, and that has this thermistor on it for making sure the battery doesn't get too hot while charging. But anyway, this little board, it uses only one wire and ground to communicate back and forth with the radio and the charger. And I looked at it with an oscilloscope, and it looks very similar to this thing here. It's just a bunch of gobbledygook squiggly lines here. You can't. It's not like normal data looking data. It's its own proprietary looking thing. and so it's not even worth trying to show it to you. It's hard to even see to capture. But needless to say, they figured out how to do it back and forth. And when it leaves the battery here and it goes into the radio on the battery contacts, it goes through this little level shifter thing here to get down to 1.8 volts before it goes into the radio's microprocessor here, and they call this a multimedia processor. So anyway, it can apparently speak the same language as the smart battery here. So that's how it talks back and forth when you hit that button for it to get the battery stats and whatever. It sends a little burst of data here to pull the board here, and then the board responds. But anyway, this is the this is kind of like the schematic of the setup. If we look at the whole reason why we're doing all of this, it would be this. And unlike a and this is the lithium-ion discharge curve. On a normal battery, the way we've always done it before is that you start off with a certain voltage when it's fully charged, and gradually, as the radio is used, the battery voltage would just gradually go down in a kind of linear fashion. And so it would just be a matter of tracking the voltage on the battery to get your current battery indication. Well, when lithium-ion came along, that totally disrupted that whole game, because on a lithium-ion battery, between 85% and 15% here, there's almost no voltage change at all. So tracking the voltage on here wouldn't do you any good. You'd have no idea if you were at 80% or at 20%. And it's only when you got toward the extremes of being fully charged or getting ready to die that you would actually see the voltage drop. So they needed to come up with some kind of other way to do it, and that's what that smart board does on the battery packs. Is it actually tracks the electricity itself, the number of electrons, the joules, and that's how it keeps track of its estimated percentage of what it has left. It's not actually doing some kind of like internal load test or something like that. It's just strictly counting electrons, and that's why it needs to have the full range when it does its count, so that it can get an accurate count. So it needs to be fully discharged on one end of it, and then fully charged on the other end, and that way it can get the full grasp of how much electricity it can actually handle. So when someone pulls it, it can give you an accurate representation. I'm going to pull this up here, and just want to go over a couple of the points about it, which is that these single wire systems, so most of them have their own protocol and use a customized charger. So that language, whatever it is, could be custom, or the order of the stuff. So I'm sure there's battery wars going on amongst the different people as to what exactly is supposed to be official or not. But anyway, the other thing is that it says the smart batteries are supposed to be able to self-calibrate by taking advantage of occasional full discharges, but in real life this seldom happens. And that's true. A lot of people, you'll get low on your battery, and they'll throw it on the charger instead of letting it go all the way till it dies. So this is how this memory effect kind of creeps up. And then later on, the last thing it says, to maintain the accuracy, a smart battery should periodically be calibrated by running the pack down in the device until the low battery appears, and then applying a recharge. So I'm careful on that language, because what they the low battery one that they're referring to is the one that goes on the for the on the radio itself, like I demonstrated with the clamshell or the power supply one, where it actually chirps at you, not just the bar itself, because that'll lie to you. But anyway, I hope that covers it and kind of takes some of the mystery out of the smart batteries. But we'll talk to you soon.